Okay, Professor Lewis here, and we're in Module E, Week 1, and there's a couple things you should have already watched and done before you are going to watch this video. The first one being, what is a strain gauge? And the next one is the thin-walled pressure vessel pre-lab lecture. Now then, if you've watched both of those, you're ready to charge ahead with us on this lab. We're going to come in and measure the diameter of this tank, and to do that, we can't use the standard 0 to 6 vernier or dial or digital caliper to do that because we can't get the blades down across the area we need to measure. That's going to take us to using a micrometer, and this is a 5 to 6, so we can measure down to 5 inches all the way up to 6 inch. We have 1 inch to travel right here on the unit. Now we've already calibrated these for you, and some points of interest of this. Before we do it, you usually want to kind of make sure these areas are going to be clean on here. You don't want to have grease or dirt on there. The other thing is when you guys use this is the thimble that we're going to turn. Typically you turn it with the main portion here, or you can come in here and turn it by this back piece, and I'm going to put some resistance on here. If I do this and I turn that, that's got a clutch, and that's going to put the correct amount of force that we need to measure on here, and that's typically about 2 pounds by standard. And so what I'm going to do is open this up, and we're going to read the diameter of that. But before we do, let's have a little session on how to read this tool.
Okay, let's learn how to read these calipers. And before we do that, we probably need to visit the concept of base 10 inch. And so what we have here is decimal inch. And for a distance from here to here is 1 inch. And what we're doing is putting 10 divisions for that 1 inch interval. And that means we have tenths. So this is going to be worth 0.1 of an inch, or 1/10 of an inch. So if we look down here, 1/10 is worth 0.1, and we can say that. Now that's how we read that. Now, most of our companies are going to come in and say we're going to machine parts to 3 decimals, and that's the accuracy of the tool that we have is 3 decimals. So we're going to call things right here 1/1000ths of an inch. And when we get to reading the tools, you'll hear us talk about 1/1000ths of an inch. So what is 1/1000ths of an inch? First of all, let's go down here and look at this. We've got 0.500. So if I was looking at a scale, that would be from here to here. That's basically half an inch is what we normally would say. But in engineering and machining and manufacturing, we're going to call that 500 thousandths of an inch. So if I had 0.125, a lot of people would think that's an eighth of an inch. But we're not going to call that an eighth of an inch. We're going to call it 125 thousandths of an inch. So I hope you get the gist of what we're doing there in terms of thousandths of an inch. And that's going to take us to our inch micrometer that we want to read. And being mechanical engineers, we like to know how things work. Now, please do not take our tool apart and verify what we're going to talk about here. There is a screw inside this mechanism right here that looks just like this. And for 1 inch distance, there are going to be 40 threads per inch. Now this picture doesn't have 40 threads per 1 inch, but the concept is 1 inch, there's going to be 40 threads, TPI. So that means 1 revolution of the thimble here is going to move the anvil and the spindle distance apart 25 thousandths of an inch right here, 1/40th of a revolution, because it's 1 inch 40 threads. And now that's something really powerful for us, that we have this nice precision ground screw doing that. So that means on the thimble there are 25 divisions on here, and each division is going to read 1/1000ths of an inch. Remember, that's 0.001, so we're going to call that 1/1000ths of an inch. Okay, so that's cool. Now I want to talk a little bit about the tool that we have in lab. It looks like this. And you guys, I'm going to make sure, quizzes and things, you need to know how to read this tool here. Most modern tools and higher quality tools are going to look like this, and we'll talk about the differences here in a minute. But let's look at this tool right here. First of all, it's going to go from 0 to 1 inch right here on the typical vernier, on the micrometer side here. You're going to have to add whatever you read here to the 5 inches because we have a 5 to 6 inch tool. But let's just go in here and read it like it's a 0-1 tool and get to know how to do this. So from here to here is 1 inch. Now this is going to line up and it's dead on, so that's exactly 1 inch right there. If we come back in here and we look, there's 1, 2, 3, 4 of these height lines. There's 10 of them. So each of these are worth 1/10 of an inch. So that's 0.1, 100 thousandths Okay, let's look in between here. So between this 100,000ths here, we have 1, 2 divisions. So if you take 0.1 and divide it by 2, that means this line is worth 0.05 or 50 thousandths. Now then, the distance from here to here, you have 1, 2, 3, 4. If you take 0.1 and divide it by 4, you're going to get 0.025. That's 25 thousandths of an inch, which, hey, that's 25 thousandths of an inch per revolution. So one revolution, we're going to go from this line to this line, next revolution to this line, and on and on and on and on. So hopefully that kind of helps you guys out. The big difference between the tool we have, this is kind of a knockoff brand tool. Higher quality tools are going to have it where they look like this, where this is your 50 thousandths line, and then down here you have your 25s down here, and they're going to be a little bit better quality. One other thing I want to talk about this tool is, you notice we have 0 and it is showing and it's on the line. So some of our measurements, we're going to have to ask ourselves, have we gone past the 0 point when we measure this? And the way to tell that is the 25 or the 20 thousandths is down here on the thimble. The 5 thousandths on the thimble is over here. So here's that 5 and that 10 that we're, or 5 and 20 that we're talking about here relative to that 0. So if this line were to be lined up here, then I probably would still see that. It doesn't mean that I'm exactly there. I have really got to look at what's on the thimble to understand, am I at this 0 yet? If I was right here, I would be a full thousandths off of where I need to be. Now, if you notice on the thimble from here to here, there's a midline here where we don't have that down here. So this tool requires you to do a lot more math, because this is worth half a thousandths. Okay, there's not a half a thousandths here because we can pick it up here. So what we're going to see is basically that's a half a thousandths of an inch there, because there are 25 divisions and those are halves. All right, let's go down here and learn how to read this tool. We have an inch micrometer. Let's assume this is a 0 to 1. We're going to come out here. Here's 100, 2, 3, 4, 5, 6. We're going to write that down. Now then, did we go past any of these other lines? Well, we went past a 25. We went past a 50. Now, did we go past this line or not? I can see it, and it looks like we went past, but if you look again, like I said, this is 20 thousandths of an inch. It's getting ready to hit this line. So just 2 thousandths off, 1, 2 thousandths right here, we would be at that line and we would be knowing where we're at. So what we want to do here is say we didn't go past that line. So we only went past the 50. We're at the 23 thousandths here, because that's what we read off of here. Here's 20, 21, 22, 23. We add all these up, we get 673 thousandths of an inch. So practice getting used to looking at this and reading it. You're going to probably see some of that, and you're going to have to read it in the lab as well. Now, I wanted to talk real quick about this little tool, just because, you know, when we talk about 0 to 1 inch micrometer, really inexpensive ones we can get probably for 40, 50 bucks. Better quality ones we're probably going to drop $100, $120. This tool could probably be anywhere from $700 to $1,000 depending on where you get it and if you get it on sale. This one measures the amount of force from here to here. And so what that's going to do is, that's that 2 pounds of force we need. This has the ability to measure the force, and so we would actually, when we measure, bring the needle up here to 0, and then we would be able to take our measurements. And so this is going to bring our accuracy of this tool way up, and this makes it so if I'm doing really high precision accurate parts, I'm probably going to spend the better money on the tools to do that. The other thing I want to point out is, guys, never leave a tool fully closed, because you have different materials and components here, and if you let them expand and contract, then they can actually destroy the tool and hurt them, as accurate as these are. So anyway, let's go back and get in the video and talk about measuring that tank.
Okay, we've just learned how to read this tool, so let's come back in here, and what we're going to do is put this across the diameter, and what you want to do is make sure you're measuring across the diameter, and you're going to see me move it up and down. And now what I'm doing is breaking across that curve, trying to hit that tangent point, and I'm going to come in here and put this up here and start turning on this until it makes contact. Okay, right there it made contact. So I'm going to raise up, and at that point I can come in here and take my reading. Now you're probably going to want to do this several times, so you're you're going to want to measure it across the diameter as well, maybe over here. So I'm going to make 2 or 3 measurements on here, just like the data sheet says, and take the average and get the diameter of this tank. Now, unfortunately, you cannot measure the thickness of the material. On the lab sheet, it gives you the thickness of the material in terms of the gauge metal thickness that this tank was made out of. And it's made out of A36 steel, so being out of steel, we know the modulus and the strengths properties of that material. In the prep video, we talked about that. So, we now know the dimensions of this tank. The next thing we need to do is talk about how we're going to hook up strain gauges. We have our P3. This is a strain indicator, and what it's going to let us do is be able to hook up our strain gauges to this. Now, in the lab sheet, it's going to talk about hooking to channel 1. Basically, we have 4 channels here, 1, 2, 3, and 4. We're going to do the one to channel 1 that is measuring hoop stresses. So you need to make sure you identify which gauge is measuring hoop stresses. And then right here we have different connections. We're going to use these first 3 connections right here, because what we're doing, if you look at the lid up here, it talks about using a quarter bridge. And the quarter bridge that we're going to do tells you how we're going to connect that strain gauge. Now again, the strain gauge does not have polarity, but we like to keep consistent. So P positive is going to be our red wire. Okay, we're going to put that in there and clamp down on that, on the exposed portion of the wire. Now what I like to do next is take the white wire, and we know that the white wire and the black wire are connected together at the strain gauge. And the reason we have 2 wires here is we have to make this bridge jump here, and we want to keep minimum resistance, and so having those 2 wires is not going to add another piece of wire or jumper that's a different length, changing our results. So basically we have the 2 wires, and we're going to take the first wire that's white and go to S minus right here. Put that in, we've got that clamped. Now we have a 120 ohm strain gauge, and so we're going to put it into the D120 right there and clip that down. That is now hooked up for a quarter bridge. So let's go ahead and hook up the second gauge as well. Okay, we have now hooked up our strain gauges to the P3 strain indicator box, and we're ready to turn this on. Now at this point we should not have the air hooked up to the tank. We don't have any air in the tank. We're going to go over there and make sure that that tank is empty. Now once the tank is empty, we're going to come in here and turn the power onto this unit. Right now we can see we have some odd settings right here. We have channels that are active and inactive. So what I'm going to do is come in here and hit channels right here, and I can cursor down. I want channels 1 and 2 on. So I'm going to turn channel 2 and 1 to be in active status, and you can see I now have channel 1 and 2 being turned on. And so what I can do at this point is come in here and make sure I have the correct bridge type in the Wheatstone bridge. We talked about that a little bit before, and so we have our Wheatstone bridge here, and it's in this picture right here, and it tells us that we've got the red, white, and black wires hooked up, and we want to be in that quarter bridge. And so if it's not in quarter, you can cursor down to which channel, push over here, and you can scroll through till you get to a quarter bridge on all those channels that you have turned on or active. Once you get that, hit menu, and we're there. The other thing that we need to do is we need to tell what kind of strain gauges we're going to have and what we're going to be measuring. So that's done under our K button right here. That's our gauge factor and scaling. And again, you're going to have a channel 1. You can change channel 2 or 3 or 4 or go back to 1. We can see the units here, and the units are going to say that we're in microstrain, and that's what we want. Again, you can cursor down and you can change that, and it's going to change your menus. So we're in microstrain, and the next thing we want to see is going to be basically the gauge factor. Now that gauge factor comes off the back of the gauges, and unless we tell you otherwise, it's going to be 2.04 for the strain gauge on there. Now then, once I have that set for both channels, I can hit menu, and that's going to be set. So at this point, the strain gauges are measuring something, but they're not zeroed out. And so just like a scale, we would have to tear it out or balance it out. And to do that, we come in here and hit balance once, hit balance twice, and then I just hit record, and it is now going to come back with 0 strain on both gauges right there. Now that we've got this hooked up and we know that we're ready to measure this, let's go over and hook the air up and make sure that we have air going to the tank. Let's talk about how to make our air connections on this tank. I suggest keeping this valve closed, and you know it's closed because the handle is coming up. If it goes down in this direction right here, the air is going to flow through this line. So let's go ahead and close this line, and we're going to pull back on this air connection right here, and you can put it onto the metal portion right there. And then release it, and it should stay. Now then, if we come in here and open this valve, we're going to let air come up here and into the tank, and we're going to be able to read that pressure. So in your lab, it wants you to go up to 100 psi. If I go too much on the pressure, I can come over here on this valve here and release pressure and let it come down in pressure. So this is how we're going to relieve pressure back here. So what you want is have one person in your lab coming in here and releasing the pressure down slowly till you get to the 100, and then have somebody record the values over there. Then come down to 80, and if you overshoot, that's okay, just a little more air in there. And you can fill it back up, and then capture those values. So hopefully that shows you how to hook this up and get your measurements from this.